Hello. We shall talk about deriving of the solution for a quadratic equation. Let's write down a general form for the quadratic equation. Ax squared plus bx plus c equals to 0. Now the solution for this equation is usually given in textbooks in this form: x equals to minus b plus or minus square root of b squared minus 4ac over 2a. Now how does this formula come about? It actually can be obtained fairly easily using what we know about completing the squares. So let's start by completing the square of that expression. So I'm going to show you how to prove this formula. Starting from that formula, when we complete the square, we start by factoring out the coefficient for x squared. Now, in this case, I could, since I have an equation, I could divide both sides by a. And this gives me, on the left hand side, x squared plus b over a x plus c over a equals to 0. So I have 0 over a on the right side and this lot over a on the left. So in the first step to completing the square, we want to have just x squared in the expression. Now in the next step, I want to rewrite this in a form where I have a bracket of x plus something squared plus something. On the right is still 0. That's the idea of completing the square, is to rearrange the quadratic expression into this form. And in order to fill in the blanks, we'll start by this blank. And the requirement is that those two blanks must be constants, meaning they must not contain x. They can contain a, b, or c, but not x down here. X is the variable. So if that's a constant, then in order to obtain this, I would think about what happens when I expand this and compare that with this expression. Now if I expand this, I will get an x squared term. I will get a term in x which I find by multiplying these two and then times 2. Now just so it doesn't get too abstract, let me write down what I mean. I'm thinking of something like, say, x plus, now I need some variable here. Let's say x plus d squared, for example. If I have such an expression, then when I square it, I would get x squared. When I expand it, I will get x squared plus 2 dx plus d squared. So that's the familiar expression. That we have. Okay. So with this, we know that the term in x would always be 2 times d. That means 2 times this number. So that means that if I compare this with this, okay, and I compare this x term with this term in x, 2d is the b over a. Okay, so that number times 2 must give me this. Therefore, this number times 2, alright, this corresponds to this. This number times 2 must give b over a. So that means that this number must be b over 2a. So I have this. Now, how about that blank? Right, I must have that, of course. Alright, that's still there. Now, if I come back to look at this, when I expand this, like when I expand this, I will get x squared, I will get a term in x, which is that one. I would also get a term in d squared. That means I get a term in this number squared. But I don't have this number squared up here. So, in order that this is still the same equation as that, I must take away this number squared. Alright, I must take away the term that I would get if I expand this. Then, this whole expression would still be equal to this. Now, just so that we are quite clear about what's going on here, let me expand this to show you what I meant just now. If I just expand this part, it would actually be x squared plus 2 times this times x plus b over 2a, that thing, squared, using that formula. Now, if you look at this lot and this lot, and then compare with this, you'll see that this and this would cancel. Okay, so those are gone. And what remains would be x squared, which is that. We have this, the 2 and the 2 can cancel, which is the same as this. And then we have c over a, which is the same as this. So that tells us that this expression is correct. Okay, so moving on from there, the point of doing this, the point of completing the square, is that it makes it easier now to solve for the x. Now, instead of having the x spread into the term x squared and another term x, right, which is very difficult to solve for x, I now have x inside part of this square. So in order to solve for x, I can start by moving those constant terms to the right. So I'm just going to carry on from this expression. X plus b over 2a squared is equal to, bring those to the right. Get minus C over A plus, that would be B let me square those, so that would be B squared over 4A squared. Now, in the next step, I can then take the square root of this. Right, remember that we want to solve for x. I need to simplify this. If I now take the square root of this, on the left side, it's just x plus b over 2a. And on the right side, I would have the square root of minus c over a plus b squared over 4a squared. Now, but we must not forget that when we take the square root, the answer can be plus or minus. Alright, it can also be minus, because if I square this answer with the minus sign will disappear and I will still get back the correct square. So therefore both plus and minus will give me what would be possible answers. And finally, you can see that we can now find x by moving this to the other side. So if I subtract both sides by b over 2a, I would finally have the solution. So this is the formula. Now, but let's check against what I've written down earlier. Now, if you look at that expression there, it does not quite look like what I have just obtained. The reason is that I would need to rearrange my answer in order that it would look like this. Now, just to get an idea of what we need to do, if you look at this, we have a big complicated expression on top of a fraction, and we have 2a below. In other words, we have just one single horrible looking fraction. So remember that we need to rearrange our answer so that we have one single fraction with the denominator 2a below. So coming back now to my answer, let's see if we can rearrange this to get the official expression. Now remember that we want to do it so that we have a 2a at the bottom after we combine into a single fraction. Now notice that we have a 2a there already. That is a good start. But that square root here is a bit more complicated. But I do have a's below. So let me start by combining those two in the hope that it will lead somewhere. So we put the two under a common denominator. I would choose 4a squared, okay, because this a, this factor of a is contained in here. So in fact 4a squared is the lowest common multiple of the two denominators. In the numerator, alright, since I've just copied over that denominator, b squared would just follow. So this gives that fraction. Now, to convert this fraction so that I can use it here, I must multiply top and bottom of this fraction so that the bottom becomes 4a squared. This means I have to multiply the bottom by 4a to get a 4a squared, and I must multiply the top by 4a also, so that it's still the same fraction. So therefore, in the numerator, I would have 4ac. You can see that we are getting there. Okay. And in the next step, let's now simplify that a little bit. Now, if I have a square root of a fraction, it's the same as if I take the separate fractions of the top and the bottom. Fraction. So the bottom is easier. Let's take the square root of that. That would be 2a. And the top would be just that. I would just copy it over. Now, but if I look at the original or the official answer, again, you see that the top here is a b squared minus 4ac. And what I have here is minus 4ac plus b squared. Okay, we see that they're very similar now. To make them the same, I would move the b squared around. So just rearrange those two like that. Finally, remember that we want a single fraction over 2a. And now that we have 2a as the common denominator, we can simply join them up and add the two the numerators in the two fractions. So that's the answer. We have derived the solution to the quadratic equation.